For centuries, humanity has looked toward the stars, wondering whether anything from another solar system could ever reach our own. That question is no longer theoretical. Right now, an ancient traveler from deep space is passing through our cosmic neighborhood, and for the first time, the James Webb Space Telescope has given astronomers an unprecedented look at it. The object is known as 3I, Atlas, only the third confirmed interstellar visitor ever discovered entering our solar system. Unlike planets, asteroids, or most comets that orbit our Sun, this object is simply passing through. Its path follows a hyperbolic trajectory, meaning the Sun's gravity cannot capture it. After its brief visit, it will disappear back into the darkness between the stars, continuing a journey that may have lasted millions, or even billions, of years. That alone makes it extraordinary. But Webb's observations have transformed this distant traveler from a tiny point of light into something much more tangible. Instead of a faint streak crossing the sky, astronomers can now study its overall shape, brightness, and the heat radiating from its surface with remarkable precision. Every new image offers clues about a world that formed around another star. Early observations suggest that 3I, ATLAS has an uneven, elongated shape rather than a smooth, spherical appearance. Its surface appears rugged, marked by countless impacts and fractures accumulated over unimaginable spans of time. Unlike freshly formed objects, this traveler carries the scars of an incredibly long journey through the galaxy. For countless ages, it has endured collisions with microscopic dust particles, constant bombardment by cosmic radiation, and repeated encounters with the harsh environment of interstellar space. Those experiences have slowly reshaped its surface into the object we see today. Webb's infrared instruments also allow scientists to study something invisible to ordinary telescopes: heat. Every object in space emits infrared radiation depending on its temperature. By measuring those tiny thermal signals, researchers can estimate what materials exist on the surface and how they respond to sunlight. The results suggest that 3I, ATLAS contains a mixture of frozen ices, rocky minerals, and complex carbon-rich compounds. None of these materials are unusual on their own. However, finding them together inside an object that originated around another star provides scientists with an incredibly valuable opportunity. It allows researchers to compare the building blocks of distant planetary systems with those found in our own. Perhaps the most exciting discovery is what these materials represent. Many carbon-based compounds detected throughout the universe are considered important ingredients for prebiotic chemistry. That does not mean life exists on this object. But it does reinforce an important scientific idea. The chemical ingredients needed to build complex molecules appear to be widespread throughout the galaxy. In other words, the raw materials for life may be far more common than once believed. As more data arrived, astronomers realized they were not simply studying another comet. They were examining preserved material from another stellar system, a natural sample delivered across interstellar space without sending a spacecraft beyond the solar system. That makes 3I, ATLAS one of the most scientifically valuable visitors ever observed. Its journey tells a story that began around a completely different star. A story that ended, at least briefly, with humanity pointing one of the most powerful telescopes ever built toward its fading light. Yet one mystery still remained. Where exactly did this ancient traveler come from? And what more could its light reveal? As scientists continued studying 3I, Atlas, one remarkable fact became impossible to ignore. This object is not simply passing by Earth. It is carrying a record of another corner of our galaxy. Every measurement collected by the James Webb Space Telescope adds another chapter to a story that began long before our solar system was fully formed. One of Webb's greatest strengths is its ability to analyze light in extraordinary detail. Instead of capturing only photographs, the telescope separates light into thousands of individual wavelengths. Each chemical element leaves behind a unique spectral fingerprint. By reading those fingerprints, astronomers can determine what an object is made of without ever touching it. When Webb examined 3I, Atlas, the results suggested a fascinating combination of frozen gases, silicate minerals, and complex carbon-rich compounds. Some regions also displayed a reddish appearance. Scientists believe this coloration may be caused by substances known as tholins. These complex organic compounds form when simple molecules are exposed to cosmic radiation over immense periods of time. Tholins are not signs of life. However, they are considered important because they represent chemistry that can occur naturally throughout the universe. Similar materials have been identified on several icy worlds and distant objects within our own solar system. Finding them on an interstellar visitor suggests that the same chemical processes may be taking place around many different stars. Another mystery involves the object's structure. Rather than behaving like a perfectly solid body, 3I, ATLAS may be a loose collection of rocks, ice, and dust held together by its own weak gravity. Astronomers sometimes describe these fragile objects as rubble piles. Although they appear delicate, many survive for astonishing lengths of time. Even so, the environment between the stars is far from peaceful. Interstellar space is filled with high-energy radiation, microscopic dust grains, and magnetic fields that slowly reshape anything traveling through it. For millions of years, 3I, ATLAS has endured those conditions while drifting through the Milky Way. As it approached the Sun, Webb detected subtle changes consistent with sunlight warming parts of its surface. Hidden pockets of frozen material may slowly release gas as temperatures increase. This gentle activity can create a faint cloud surrounding the object, much smaller than the spectacular tails seen on many familiar comets. Even this weak response tells scientists something important. After an unimaginably long journey through deep space, some of its original volatile materials may still remain preserved beneath the surface. That discovery has broader implications. If one interstellar object contains complex chemistry and preserved ices, countless others may carry similar ingredients as they travel between stars. Planetary systems are not completely isolated. Over billions of years, gravity can eject asteroids and comets into interstellar space, allowing them to wander across the galaxy. Occasionally, one of those travelers enters another stellar system. In that sense, the Milky Way may slowly exchange material between its stars. Every interstellar visitor becomes a messenger from a place we cannot yet explore directly. Instead of launching spacecraft across impossible distances, nature occasionally delivers samples to us. That is what makes 3I, ATLAS so valuable. It offers scientists a rare opportunity to compare another planetary system with our own using real observations rather than computer simulations alone. Perhaps the greatest lesson is not about one object. It is about perspective. For generations, humanity viewed the solar system as a largely isolated neighborhood. Interstellar visitors remind us that our cosmic surroundings are part of something much larger, a galaxy where material, chemistry, and history moves slowly from one star to another. No evidence suggests that 3I, Atlas is artificial. No confirmed observations indicate technology or intelligent origin. Instead, it appears to be something just as inspiring, an authentic relic of another stellar system, shaped entirely by the natural forces of the universe. As it continues its journey away from the Sun, its light will gradually fade from our telescopes. But the information it carried will remain. Every spectrum, every image, and every measurement will help scientists better understand how planets form, how stars exchange material, and how common the ingredients for life may be across the galaxy. Long after 3I, ATLAS disappears into the darkness once again, its brief visit will continue to influence astronomy for years to come. Because sometimes the universe doesn't reveal its greatest secrets through dramatic events. Sometimes it simply sends an ancient traveler across the stars and waits for us to notice.